In this video, I'd like to take a look at an example of computing curvature using the alternative formula that is the magnitude of the cross product of the acceleration and the velocity divided by the magnitude of the velocity cubed. So that the vector that I want to work with here is a trigonometric vector 4t, 3 sine t, and 3 cosine t. And what I want to do then is compute each of the elements, the velocity vector, the acceleration vector, and the magnitude of the velocity, the speed. Okay, so those three calculations, and that you can kind of, very easily just take our 3 cosine t and minus 3 sine t as the velocity, and now do it one more time for the acceleration. I get 0 in the x component, minus 3 sine t and minus 3 cosine t. Okay. So the magnitude of velocity is our typical square root of the sum of the squares of the components, and that when I do that, I find out that of course, the cosine squared and sine squared is 1, so I get 9, the root 25, so the speed of this is 5. And then all I need to do is just compute it, and that I end up with 125. Okay, so now when I go ahead and do my computation, kappa then is going to be the cross product. Here, let me put the 125. So 1 over 125 times the magnitude of these vectors, 0, minus 3 sine t, minus 3 cosine t, and then that's the acceleration, and I'm going to cross that into 4, 3 cosine t, and minus 3 sine t. Okay, so let me just set up the computation, and so that I'm going to take the magnitude of an I and a j and a k component, and then put in my acceleration. That was the first one, sine t, minus 3 cosine t, and the velocity 3 cosine t minus 3 sine t. Okay, so that now we have this set up, and what I want to do then is look at each of these individual components and then figure this out, right? So now we're going to have an I component, right? So I disregard these rows and compute the submatrix here, and so that this product is going to be 9 sine squared t, 9 sine squared t, and then I'm going to subtract this product, minus a minus 9 squared t, so that's plus cosine squared t. Okay, and that's my I component. Whoops, I component. Okay, so then the j component is subtracted, and I'm going to go ahead and take out those values, right? So I don't do the j column and row and end up with my 0, 4, and my cosine. So when I use the 0 here, 0, and combine that with that, I'm going to get a 0, and then so I'm going to subtract this product, which is a minus 12, which makes a minus minus, which makes a plus 12 cosine t, and that's the j component. Okay, so one more, we'll do the k component, and that is disregard this one, and go across here. Again, I get a 0 in the first position, and then a minus 12, which ends up as a positive 12 sine t in the k component. Okay, so now putting it all together, that I end up with my kappa is this cross product, 1/125th, times the magnitude of that vector, 9, because the sine and the cosine add together to get 1, minus 12 cosine t, and 12 sine t. Okay, that's the vector, and then I find the magnitude of that. You do that computation, I get 144 cosine squared, 144 sine squared, and 81 from the 9, which makes 225, and I take the square root of 225 and get 15. Okay, so that I always reduce to lowest terms, 3/25, and that's my value of the curvature for this curve, our vector, this trajectory. Okay.